Hello, my name is Halina Franchevska and I'm presenting you a presentation about information system for detecting fetal ECG signal in the presence of interference. On this slide you can see table of contents with such point as introduction, algorithm for extracting fetal ECG signal, generation of fetal ECG signal, detection fetal ECG signal, the adaptive filtering method for a mixture of fetal ECG signal, and the results. Congenital heart defects are a significant cause of infant mortality, emphasizing the need for improved diagnosis and treatment. Fetal cardiodiagnostic systems can monitor the fetal electrocardiogram signal, but reliable signal selection is challenging due to its weak nature and susceptibility to interference. Existing methods for extracting useful fetal ECG signal as blind signal separation, synphase and component methods, spectral method, bispectral processing, the method based on Neyman-Pearson criteria, have limitation as they do not consider time frequency characteristic and phase time parameters simultaneously. Therefore, a new algorithm is proposed to address these issues and provide more reliable results. The algorithm involves several steps. First, maternal ECG signals are registered and filtered to remove noise. R peaks are then identified using a peak detection algorithm. The second step focuses on detecting fetal ECG signals by analyzing morphological differences and applying low-pass and high-pass filters. If fetal signals are detected, the algorithm proceeds to the third step, which involves adaptive filtering to remove maternal noise and enhance the fetal ECG signal. The filter coefficients are updated in real time based on the maternal, fetal, and noise components. Let's move to the generated simulated fetal ECG signal. On this figure, you can see the sampling frequency refers to the number of samples taken per unit time. In this case, a sampling frequency of 1000 Hz was used, meaning that the signal was sampled 100 times per second. The duration of the signal was set to 10 seconds, which is typical length for ECG recordings. The fetal heart rate was set to 140 beats per minute, a common value for a healthy fetus. Next, a maternal ECG signal was generated using a mathematical model that simulates the electrical activity of the maternal heart. Once the maternal heart ECG is generated, a fetal ECG signal generated by modulating it with a fetal heart rate signal. The fetal heart rate signal is modeled as a sinusoidal signal with a frequency that corresponds to the fetal heart rate. By multiplying the maternal ECG signal with a sinusoidal signal that corresponds to the fetal heart rate, a simulated fetal ECG signal is generated. To simulate real-world conditions, white Gaussian noise with a signal-to-noise ratio is added to the simulated fetal ECG signal. This noise addition is crucial for creating a more realistic signal, reassembling actual fetal ECG recordings. The fetal ECG signal in the mother's womb is both periodic due to physical causes and stochastic due to the influence of different types of interference, which is why it is mathematically modeled as a periodically correlated stochastic process. The representation of the mixture of fetal and maternal ECG signals as a periodically correlated stochastic process justifies the applicability of well-known statistical analysis methods, synphase and component, for computing correlation components as indicators of fetal signal detection in the mixture. The observed fetal ECG components are concentrated in specific frequency ranges, while the maternal ECG components occupy a different frequency range. This clear separation of components quantitatively confirms the presence of fetal signals in the mother's uterus, which holds significance for prognostic diagnosis. The adaptive filtering method is commonly used to separate the fetal ECG signal from the mixture of ECG signals. This technique employs adaptive algorithms that continuously update filter coefficients to attenuate unwanted components while preserving the fetal ECG signal. Once the adaptive filtering process is complete, a filtered fetal ECG signal is obtained. This signal primarily consists of the fetal cardiac activity with a reduced level of noise and artifacts. The filtered signal provides a clearer representation of the fetal heartbeat. To accurately analyze the fetal ECG signal, peak detection algorithms are applied to identify the R peaks. These peaks correspond to the fetal heartbeats and provide essential information about the fetal heart rate and rhythm. In conclusion, extracting the fetal ECG signal from a maternal signals is a challenging task, but advancements in signal processing techniques have significantly improved the accuracy and reliability of this process. Further research and development in this field hold great potential for enhancing prenatal care and improving fetal health outcomes. Thank you for your attention. Bye.